So this is a tetrahedron. So you can see it's like a triangular based pyramid. You can have 1 triangle, 2 triangle, 3 triangle, and on the other side is a 4 triangle. So it has faces marked 1 to 4. That's what a tetrahedron is. So you are told here, a boy tossed a coin and a tetrahedron. What is the probability of getting 3 on the tetrahedron and 1 on the coin? Head on the coin, 3 on the tetrahedron. On the coin, we want to get a head. On the tetrahedron, we want to find the face marked 3. Now remember, we have said a tetrahedron here, a tetra here. It has a tetra. It has faces marked 1, 2, 3, 4. So the probability of getting 1 in the tetrahedron is what? Is just the normal formula, favorable outcomes out of total outcomes. And in this case, favorable outcome for getting 1, if you toss it once, you can only get one once. Out of how many outcomes? 4. So the probability of getting each and every face, probability of getting 2 on the tetrahedron, if you toss it once, is also going to be 1 over 4. Okay? Probability of getting 3 is also going to be 1 over 4. There's no need of me writing all of them. 1 over 4. Okay, so you want to get a 1 on the coin and a 3 on the tetrahedron. The word here is and. Now, the probability of getting a head on the coin, the probability of a head occurring is probability of a head occurring normally is a half. Probability of a head occurring is 1. So a head can only occur 1 out of 2 outcomes because you have either a head or a tail. So a head can only occur 1. And probability of getting this one, I'll put it wrong place. And the probability of getting a 3 on the tetrahedron, a 3 on the tetrahedron, 3 on the tetrahedron, getting a 3 on the tetrahedron is a quarter. So in short, what we are saying is a half you multiply by a quarter. 1 divide, you multiply by 1 over 4. So it is 1 times 1, 1, 2 times 4, 8. So the answer is 1 over 8. Some people can even go and some people can even go and write it as 0.25. 0.125. Yeah, you can go and write it as a decimal, or you can even write it as a fraction if you want. So as we can see, these are what we call independent events. The probability of us getting 3 on the tetrahedron and 1 on the head on the coin and 3 on the tetrahedron, hakuna vile ukisema ati we get a head on the coin in the tetrahedron we won't get this. No, there is no event which is limiting the other one from occurring. All of them are occurring together, and that is why we use the word and. And in and we use multiplication. Alternatively, you can do this. You can have a head and a coin, tetrahedron 1, 2, 3, 4, and then you multiply 1 and a head. So 1 and a head, a 1 and a tail, a 2 and a head, a 2 and a tail, a 3 and a head, a 3 and a tail, a 4 and a head, a 4 and a tail. So a 3 and a head, they are only occurring 1 out of sample space is 8. So 8 possible outcomes. You can also do this. You can also do this. But this one can only happen for 2 things. That is 2 coins, two tetrahedrons, a coin and a tetrahedron, a coin and a die, a this and a this. That one we can also talk about it. Actually, we can very quickly here. We can have a case of a coin and a die. We see what you're going to get. Let me have a coin and a die. So let me come to this page and show you. If I toss a coin and a die together, a coin is going to have a head and a tail. Okay. A head and a tail. So a die is going to have 1, 2, 3, 4, 5, 6. So number 1 here, we are going to get a 1 and a head. Here we are going to get a 1 and a tail. Here we are going to get a 2 and a head. Here we are going to get a 2 and a tail. Here we are going to get a 3 and a tail. And here we are going to get a 3 and a head. And so on and so forth. So the probability space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can form any kind of a question, and then from there you can now solve it. So that is how simple it is to find that independent probability. Let's come to the machine, the issue of the machine here. And so we are talking about factory. There are 3 different machines in a factory. 3 different machines in a factory have different probabilities of breaking down during a shift, as shown on this table here. So the probability of machine A breaking up is 4/15. Machine B breaking up is 3/10. Machine C breaking up is 2/11. Okay. Then let me note this somewhere. A is 4/11. B is 3/10. C is 2/11. Find the probability that all the machines will break down in one shift. The probability that none of the machines will break. The probability that none of the machines will break down in one particular shift. None. So we come here. So you are going to fill that table on your own. So let me insert another table here. There was 1, 2, 3. 1, 2, 3. 1, 2, 3, 4 here. Okay. So in my machine, I have machine A here, machine A here, machine B here, and machine C here. The probability of A breaking, probability of machine breaking, I will go on and say machine not breaking. So that we can calculate that one. Machine not breaking. So probability of machine A breaking is 4/11. The probability of machine A B, the probability of machine A not breaking is 1 minus the probability of machine breaking. Machine A breaking. That's the probability of machine A not breaking. Let me just come here and write it, what you can see here. Okay, yes. Nitaweza kuweka iko sama bado itateremka huko chini. So that is what I wanted. So the probability of machine B not breaking, which is that column B, is again going to be 1 minus have not, this one is B breaking. So B not breaking is written like that. 1 minus the probability of B breaking. And finally, the probability of machine C not breaking is equals to 1 minus the probability of machine C breaking. Machine C breaking. B breaking is 3 over 10. C breaking is 2 over 11. So in short, we can see the answer to this one is 1 minus 4 over 11 is like 11 over 11 minus 4 over 11, which is 7 over 11. My probability of machine B not breaking is A is 10 over 10. So it's going to be, 7 over 10. And 2 is going to be 9 over 11. 9 over 11. So if you say 9 over 11 plus 2 over 11 should give you 11 over 11 or equal to 1. 7 over 10 plus 3 over 10, 10 over 10, which is equal to 1. 7 over 11 plus 4 over 11, 11 over 11, which is equal to 1. So all machines break down in one shift. Down in one shift. Yani kwa shift moja machine zote ziharibike. So it is the probability of A breaking and B breaking and C breaking. A breaking, B breaking, and C breaking. So in short, it is 4 by 11 multiplied by 3 over 10 multiplied by 2 over 11. That answer, you can solve it for yourself there at home. This is the probability of all the machines breaking down in one shift. That's the first question that we have been given. Now, the second question was asking us the probability of machines not breaking down. Let me come here, see. Probability that none of the machines will break down in a particular shift. This one, we can do it two ways. The probability that probability no machine breaks down. This one can be solved by 1 minus all machines break down. Which is going to be, this one can be found by 1 minus into brackets. 1 minus all the machines break down. Remember, all the machines breaking down is 4 over 11. Then you multiply by 3 over 10. And then you multiply by 2 over 11. The machines break down in one shift. Or none of the machines break down. None of machines break down. So this is this is going to be the probability of A not breaking down and probability of B not breaking down and probability of C not breaking down. Which is 7 over 11 7 over 11 multiplied by 3 over 10 multiplied by, not 3 over 10, sorry, 7 over 10. 7 over 10 multiplied by 9/11. And then you will find your answer there. And then you will get your answer. So this answer that you are going to get here, the answer that you're going to get here is the same. 1 minus all machines break down. That is 1 minus into brackets 4/11 times 3/10 times 2/11, or none of the machines break down, which is 7/11 times 7/10 times 9/11. The answer that you get here and the answer that you get here, they are the same answers. That is the probability none of the machines will break down. And those are called independent events. Those are independent events. And so I'm so happy now to get to that point. So I will now teach this with the aim of finishing by talking about the tree diagram. Even if I don't finish a tree diagram today, I'll just have like 20 minutes in the next lesson to finish the tree diagrams. So a bag contains 8 black balls, 5 white balls. 2 balls are drawn from the bag one at a time. So you have 8 black balls plus 5 white balls. Total number of balls are 13 balls. Total number of balls are 13 balls. Now, find the probability of drawing a black ball and a white ball. In that order, a black ball and a white ball, number 1, without replacement, and number 2, with replacement. 8 black, 5 white. So a bag has 8 black balls and 5 white balls. So 2 balls are drawn. Unatoa balls mbili. To draw is to remove them. So number 1 is we are being asked the probability of picking a what and a what. Let me check very quickly. A black and a white with replacement and without replacement. So the examiner wants here to pick probability of picking a black ball and probability of picking a white ball with replacement. So number 1 here, I'm going to do without replacement. Without replacement means, no, let me talk about with replacement. With replacement means that the total number of balls is going to remain the same. So if I pick a ball, for example, the total number of balls, because I have to talk about total number of balls, total balls is equals to 8 plus 5, which is 13. It is given by 8 plus 5. So I want to pick with replacement, which means if the first time I am going to pick, I want to find the probability of picking a black ball, and then I return the black ball. Okay. Number 2, what is Solomon, what are you saying? Yes, Solomon?
I wanted you to pardon on before going further, you pardon, you come up again over the
what?
About this of picking the balls and replacing them. Once tena vizuri, sijaelewa.
Now, with replacing the balls means that if I have 8 black balls and 5 white balls, total number of balls is 13. That is 8 black balls plus 5 white balls. Total number of balls is 13. With replacement means, for example, I want to pick a black, because now here I've been told I pick a black and a white. Black and white. So with replacement means I will pick a black. Now, if I pick one black ball, how many black balls are there? The black balls are 8, which means the total number of balls is how many? If the total number of balls is 13. So if I pick the probability of picking a black ball, let us go first of all the probability of picking a black ball in each and every scenario now. Probability of picking a black ball here in this case is 8 favorable outcomes out of a total of 13. So if I'm doing it with replacement, if I want to pick a black ball again, I'm also going to do it 8 over 13. That is with replacement. Without replacement now, if I pick one black ball, how many black balls are remaining? 7. If 7 balls are, if now I'm left with 7 black balls, so it is 7 plus 5. So it means that in the second time, the probability of picking a black ball is not 8 over 13, but it is 7 over 12. Same case, I come to the white ball here. The probability of picking a white ball now with replacement, how many white balls are they? 5. 5 favorable outcomes. 5 out of how many? 13 black balls. So if I pick one white ball and I don't return it, so how many white balls are remaining there? 4. What is the total number of balls? 4 plus 8. These are black. So it's going to be 4 plus 8, meaning that the total number of balls that are going to remain is 12. So the probability of picking a white ball without replacement now in the second time is going to be 4 over 12, which can be simplified further. That is what I mean, Simon. And we are approaching our last 10 minutes. Leo lazima tumalize lesson mpaka 5. We have to finish this lesson so that we are able to cover some bits for the sake of the January intake, because they also need to cover their syllabus. So that is what with replacement means, and without replacement, that is what that means. Solomon, umesikia sasa vile tunafanya? Solomon? Okay, atainua mkono tena. So that is what with replacement or without replacement means. So number one, I want them to do it with or without replacement. With replacement. So I want to pick a black ball with replacement. Probability of picking a black ball, so a black, so it's the probability of picking a black. And probability of picking a white ball. A white. I'm now replacing. So if I'm replacing, the total number of balls will remain the same. So first of all, what's the probability of picking a black ball? 8 over 13. So I've picked a black ball. And then after I've picked it, I return the ball. So the balls still remain what? We remember if I pick from 13 balls, if I pick 1, they remain 12. So if I return again, they go back to 13. Okay? So it is 8 over 13. Now, I want to pick a white ball. The balls are still 13. So how many white balls are they? 5 out of how many? 13. So there's the probability of picking a white ball and of picking a black ball and a white ball with replacement. That's number one. Number two, without. Without, this is what it means. I pick, number one, I'm picking a black ball, and then the second time is when I'm picking a white ball. So if I pick a white ball, if I pick a black ball, sorry, there are 8 out of 13, there are 8 black balls out of 13 black balls. Now, and I want to pick now, I am not replacing. So the ball that I've picked, there were 13, nikishaitoa, sirudishi tena. So the number of balls remaining there are how many? 12. So I want to pick a white ball. How many white balls are they? 5. But how many total balls are they? 12. This is what with replacement and without replacement means. Please do your calculations at home. I will not do any calculation. It is very simple. 13 times 13, I am sure that you know the answer is 169. So for example, the first answer, I can say it was 40 over 169. This one was very simple to calculate. I'm very sure. The second one, I'm sure it is going to be a bit, different. That is with replacement. So 8 times 5, I know is 40. This one is 40. 13 times 12. I don't want to calculate this, but let me just calculate it. You're left with 6 minutes. 13 times 12. 13 times 12 is equals to 156. Kumaanisha hii lazima tuta simplify. So 40 over 156. So you can say by 2 by 2, sijui utafika wapi. So you can simplify here. I think you say, can 4 go here? 4. 156, can I divide 156 by 4? I don't know whether I can divide that one. I don't know how fast I am. 56 divided by 4. 39, yes. So by 4, 10. By 4, 39. I'm sure it cannot go below that. So that is what you get without a replacement. Okay, I was answering Solomon there. So let's continue. I know this case of with replacement, without replacement can confuse you a lot. Yeah, but it's something that you should be able to do. Yes. Now, let me pick what? Let me pick how many balls. Okay, let me talk about this. Kamau Njoroge and ndio video ya kwanza mbaki dakika 4. Namalizia hapa kweli. Did we do all the things that we were supposed to do here? A black with replacement, a black without replacement. Hapo tulikuwa tumemaliza. A white and a black. Yes. So next we are going to come to this. Na hapa ndio nataka tumalizie, but I think we are going to look at least this. Now, before we finish this, there's something that I have realized here. Now, the question was asking us to take 2 balls, a white and a black. I could pair a black and a white. I could pair order. So I want now to come to the order. And this is where the confusion might get in. So I'm asking you to be very keen here. Let me explain whatever I want here. With replacement. So the first one, we got the answer as that. Now, I want to say there's another scenario that can happen here. A black, so I was picking a black and a white in that order. What about if I can pick them in 2 orders, a black and white, okay? Or I can pick a white and black. Hapa ninataka uelewe vizuri sasa. We have not been told in a specific order. Niguze hiyo font iko hapa. Give it a smaller font like 20. so that we can be able to see a bigger part. So what I've done here in the first method, I have, with replacement, I have picked a black and I've picked a white. Let me come to the second scenario. Second scenario is or I pick a white and a black in that order. Now, so I have picked the first one. So I've picked, this one I've picked here, it is black and white. So I'm going to come here and add or. I want to pick a white and a black. So with replacement, it means the total number of balls is going to remain as 13. Yes, I will answer Ade's question last. Not this time, so I'll answer it last. So we are remaining with 1 minute. So we are going to come back for the final 20 minutes. Yes, we can continue from there. But I will have written whatever I want right here. So picking, I want to pick a white, then a black. How many white balls are they? 5. Out of how many? 13. And then I pick a black ball the other time. Now this time I'm replacing. So there were 13, I pick one, they remain 12. I return the one, they remain 13 still. So when I'm picking the second one, the black one, they are also going to remain 13. So I have this one, yeah, which is also 40 over 169. The answer is still the same. So in short, here we are saying the answer is going to be 40 over 169 plus 40 over 169. And the answer is, when you come back, we are going to solve this. So you are waiting for that 1 minute to elapse, and then we join for the last 20 minutes.